Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Ved. I'm with Atlanta Functional Programming. Uh, I'm taking a small break from our normally scheduled program of continuing our modernization of the CL Neo4j library to do a small Ask Us Anything. Uh, to give you guys some bits updates on the development of that. I started refactoring some of the code, but I didn't get a chance to work out some of the issues that we discovered last week related to the creation of a macro, particularly so that we can encounter and start inserting relationships for existing nodes inside of the graph database. As soon as I have something more definitive, um, unfortunately, I had a pretty busy week, so I was unable to get to that. I will do a follow-up episode, maybe even something earlier in the week, just to give you guys sort of a snippet of how that macro generation is working out, and hopefully we could get some questions on that. Don't worry, I will let you know via the appropriate notification channels, particularly on Meetup and stuff, if and when such a stream will happen during the week. For those of you who are not already a member of the Atlanta Functional Programming Meetup, I suggest and encourage you to subscribe to that meetup so that you could get announcements for when we have talks upcoming. And for those of you who are on YouTube, of course, as usual, please subscribe to the YouTube channel for latest updates on that front. I will go ahead and try and schedule some of those on YouTube as well, just so that our YouTube subscribers will be able to be aware of those upcoming talks too. Before I start today's discussion, which is merely a general Ask Us Anything, and for folks who are joining us on the stream, and for the folks who are on our meetup through the Jitsi channel, uh, as usual, Atlanta Functional Programming is looking for uh, speakers. Any topic functional related is open for discussion on our meetup. We try to encourage functional programming as a primary paradigm for large scale software architectures, although we love to encourage people to do object oriented functional kind of mixture architectures to so sort of see how they are complementary technologies, not a exclusive or like many modern programming languages sort of try to brainwash people into thinking. um, if you have a topic that fits this, and again, we are language agnostic, although we do a lot of Common Lisp and Haskell focused talks on this channel, as well as our in-person meetups. We are language agnostic in any programming language that has functional features or allows you to adopt some sort of ability to write in a functional style, whether through higher order functions and so on, is open to, you can feel free to present here. Just go ahead and notify me. I am Bugram on the Functional Programming Slack channel, as well as I squat on the Lisp Discord server. I've already posted this information on our previous episodes. I encourage you to go back to our previous episodes of the Common Lisp Study Group to get some of that information. I will try and add it to the YouTube description before the end of the day today when we when this video gets published. And so if you want to get some of that information too, then you're going to have to wait a little bit before that information is posted. Uh, Today, a couple of topics that I wanted to kind of discuss that just at least on the top of my mind, and then it's kind of an open floor discussion. If there are particular questions, anybody who's following the stream, feel free to add questions on the top chat. I will address them as I see them. Uh, is just some interesting things that I've been reading up on related to just a couple of features in Common Lisp that I was thinking about just as I was exploring in REPL. mainly when I was focusing on trying to see how, to modernize some of the Neo4j stuff. One of them a was defined method combination, which is a particularly interesting topic. Um, I thought it would be useful for us to kind of look at the hyperspec and go through the hyperspec of what it's talking about, and then see in what ways we can explore and leverage defined method combination. To give some background on method combination for folks who are brand new to Common Lisp or watching this video, method combination is typically used inside object-oriented programs, particularly when you are using def method and def generic. In the generic function architecture, you can actually predefine a method combination on top of your def method declaration so that the folks, the REPL when and Common Lisp compiler, when it actually sees this method combination annotation, it will actually generate code to determine how method dispatch is done. Okay. To put this in more of a traditional object-oriented context, I thought it would be useful for us to go back and look at the hyperspec definition. If you just give me just 1 second here, which we can actually look at by simply doing. Right, I have to open up a scratch buffer for me to do this. Um, Hold on. Let me create a scratch buffer. Let's do afp.lisp. Okay. So to access the hyperspec, there's a couple of ways. Obviously, one way is for you to go and look at the internet to do this, but I thought it would be useful to show you how slides or Sylvester will actually allow you to access it. You could just simply type in do me max MH capital H to get lookup symbol and Common Lisp hyperspec, and it will shoot out to your default web browser with the actual hyperspec information. Give me just 1 second. I may have to go and change my screen here to actually show you guys what this hyperspec looks like. 1 second. There we go. Then do this. Yeah, sure. Okay. So in traditional OO programs, what defined method combination does is it does what's called standard method combination. Okay. Standard method combination is just really going from most generic to most specific. Okay. And as you can see here, um, it goes from most specific first to most generic. It's in the opposite order. Standard method combination is already provided to you. So when you do a def method, it's assuming you're doing standard method combination, which means you're going to be, when you subclass and you create a method that has a specialization on that subclass of the basic class, it will go ahead and call that method first, that special subclass's method first before reaching out to check to see if there are more generic methods to get invoked by using a method dispatch mechanism called call next method. Now, we've already kind of discussed a lot of how standard method combination is done on this channel. For a more detailed review, I encourage you to go look at our past episodes on object orientation. And there's a very nice book by Sonia Keene on object oriented programming in Common Lisp that we also covered that went through some of this information too as well. But one thing that we didn't kind of cover, and this is something that I wanted to cover here, is um, what defined method combination does is, and what this is if you want to change um, the dispatching mechanism for subclassing a particular hierarchy, you have the ability to actually, instead of creating a lot of infrastructure for doing the dispatch, leveraging the Common Lisp infrastructure defining a method combination for your specific use case, and then um, go and use that by just attaching the annotations to the def method declarations, and it will use that method dispatch later on. Where this is particularly interesting for me, and this is something that I've been looking at myself in my free time, and I'm trying to figure out ways of actually leveraging this, is actually recreating things like MapReduce, where you're dispatching to other nodes inside maybe some remote nodes. They could be remote Lisp machines. They could be separate threads running on your Lisp repo, your current Lisp image. But at the end of the day, the dispatching mechanism is actually simply defined through the method combination and not through any sort of like additional annotations and stuff. So you can actually leverage this existing infrastructure to do that kind of dispatching mechanism. I thought it was a particularly interesting thing. Um, to show this example, I thought we could look at the example that was provided in the quick short form of method combination, just to give you some sort of flavor on how some of this stuff works. I'm still looking at trying to get through a working example of what I was talking about before. Um, but this is kind of what's already in the hyperspec that I thought we could at least go through and see if we can um, leverage some of this stuff already. So some of the basic examples in this, and again, if folks are having any questions, just feel free to post in the chat or the uh, the Jitsi chat discussion, and I'll go ahead and address them as I see them. I thought we'd just look at some of these examples that are shown here in the hyperspec to actually look at what this is actually doing. So there's two kind of notations that we can actually leverage. The first one is what they call short form with method combination, as illustrated by this simple example of creating a method combination for anding a series of methods happening. So what this happens is um, it will actually go through and create an and annotation. Okay, I'm using annotation here, but it's just a keyword that ends up getting recognized when it's parsing the def method declaration. And this and basically tells the Lisp REPL or the Lisp compiler infrastructure that the series of functions that are defined for this def generic and all of its subclasses, each of these functions in this and method combination approach will get anded together. So that means most specific will get the subclass will get called first, and then its result, which could be a boolean in this case, since we're anding everything, um, it will then be anded with the invocation of its parent class, class's implementation of a def method, and so on and so forth until the base class of the hierarchy is actually ultimately called. This again is mainly for the purposes of dispatching and allows you to actually change the way your results of functions can be composed inside of the object hierarchy that was created by the designer, which I thought was pretty interesting. There's some specifics here that I thought I'd also go through just because it's being covered here, and that's actually inside of this man page that I thought it would be useful to go through, and that is the where was it? It was yeah, it's probably easier to go through it this way. It is the different forms of defining the method combination. Again, we saw the short form example earlier. That mainly includes you defining a def generic with the documentation string, whether or not it is providing an identity with one argument or not, and what is the actual operator that you're actually leveraging. So in the and example, okay, so there is a question. Um, Let me just quickly explain this, and I'll address that question. Um, the operator usually situations where you're doing and or whatnot can actually leverage the identity with one argument functionality, and then you could just define your def methods using single operators. If you're doing actually functional style stuff and trying to make methods to actually be somewhat composable, I I believe based on what I've seen, this is one way of actually getting it close to that kind of dispatch mechanism. Um, so there's a question here: how to find a job in Common Lisp? Okay, so for folks who are looking for jobs in leveraging that leverage Common Lisp, um, there are several avenues to actually go look for Common Lisp oriented programming jobs. I've I've seen quite few ways of uh, tweaking the LinkedIn search parameters to allow you to trigger the ability to leverage and find jobs that are in Common Lisp. Some examples and some companies that today are using Common Lisp. Some modern examples is um, one company is uh, what's it most recently, Grammarly. Grammarly actually leverages Common Lisp for their grammar checking engine, amongst other things in their infrastructure. Another one is there is a couple of security outfits. I'm forgetting their names right now in uh, New York that you can actually find it through LinkedIn that also leverages Common Lisp. Um, of course, Autodesk, their Auto Lisp feature has been around for years, and it's still well maintained. Um, there's also various companies that leverage Clojure, which isn't Common Lisp, but if you have Common Lisp exposure, switching over to Clojure and actually leveraging Clojure for in a particular Common Lisp style is possible, and that's also a possibility. Um, Google is another place that surprisingly still leverages Common Lisp. They actually, it's because of their purchase of a company called ITA Software that back in 2000, believe it was 2008 at this point, 15 years ago, that whose entire system was written in Common Lisp that they ended up encountering and have subsequently have been maintaining for that code base. Um, there are many other avenues on there. There's a couple of functional programming companies too, as well. If you're in Europe, especially, there's quite a few companies that leverages Common Lisp there. Unfortunately, I don't remember how I encountered them specifically. There are you could. It's usually just a tweak in the job search parameters of the different job search sites that allow you to look for Common Lisp opportunities, but there isn't any Common Lisp focused job site, just because every company usually they shift with the how the market is, and if they have existing utilities, they are always in need of programmers leveraging that information. Other questions? Now, I would like to point out for those of you who are wondering about the job prospects inside Common Lisp, Common Lisp isn't just about for learning Common Lisp isn't just obviously we want to also leverage it in our day-to-day work because it'll make us better programmers in the language itself, but has many lispers famously said learning Common Lisp itself, even Scheme, and any other Lisp for that matter, um, it really changes the way you approach programming, and it allows you to start making some decisions even in your language of choice in a particular way, like knowing when a syntactic abstraction may be necessary versus just simply a higher order function. Designing and implementing stuff in a more functional style, because composition is much easier to parallelize, just because of the immutability properties of most functions. Um, Trying to minimize the use of of what's it pointers and dynamically allocated memories. So and yes, yes, there is a response here in our YouTube chat that I think I'd love. I'm going to just repeat, and I enjoy this every time I see it. Once you know Common Lisp, every day is difficult with other languages. This is absolutely true. I mean, you will end up wondering why you can't just do this with why a reader macro doesn't exist. But to point out hygienic macros, at least, and some of the macro transformations have been leaking themselves slowly but surely into other languages. Most recently, for folks who have looked at uh, what's that, Rust. Rust macros and derived macros and attribute macros that are created inside Rust is very much is in normal macro mode. It doesn't have compiler symbol or reader macros like Common Lisp, but that's only because of the fact that Rust itself is a compiled language. And usually for compiler macros and symbol macros, for that to work effectively so that you can actually debug them a little bit more. You'd want to have an interactive programming environment so that you can actually see your results and be able to tweak the functions as you are working through the macro generation. Whereas with Rust, just doing Rust to Rust compilation and Rust to Rust source generation is perfectly all right, and it's actually pretty decent. But it does come from the Lisp world. So you can adopt at least some things from Common Lisp into other languages, but not everything. Okay, other questions? Okay. So the one thing that I wanted to kind of mention and why I wanted to bring up this method combination stuff is because the long form is the more flexible version of this defined method combination sort of design, this function. And that requires you to talk about the order in which your dispatch mechanism works and whether or not uh, specifically it is a requirement. And the required P is hold on, I gotta pull up what this was. I forgot off the top of my head what the required P purpose was. P was name operators often the same symbols, but not required. Ah, here we go. Okay, that's right. So the required mechanism inside of a defined method combination in the long form, especially is talking about whether or not you need a specific method defined for this particular group and whether or not that is required. All right. Um, it if the method group that means then if you don't have at least um, uh, what's it? Uh, As soon as you realize that the method group is empty and it's particularly required, you end up getting an error thrown to your REPL. And we'll just say that we cannot invoke this function. The default of this is particularly nil, just because it tries to maintain flexibility. This is important, especially if you're trying to, define a generic and later on decide that, okay, this is how we're going to define the particular method on some base class hierarchy. Um, So let's see how this looks in the long form. So we talked about the short form earlier. Again, that's a very quick thing for the and operator. In the long form of this, and we could see this sort of stuff if we switch back to our let's change back to our REPL. if we end up trying this particular idea by just simply trying the two ways of defining the method combination. The first one, of course, I'm just going to go ahead and just copy this straight from the oh right, hold on, let me just close that. I'm going to copy this from the hyperspec, and then we'll just see what this looks like. Copy, paste. Okay. So let's say that we define this brand new method combination here. Okay. Simple short form example of method combination. And again, when we do the long version of this, you'll end up seeing this going to be the same sort of issue of redefining the method combination, and then I may have to end up restarting my REPL. Just giving a heads up. Sometimes I've seen name conflicts happen when I do this. When we do this, oh, that's right. I have to make a new package for this. Let me just do dev package, test, RV test, and we're just going to go ahead and say we use, let's do CL. Hopefully this use won't necessarily, this might actually end up causing some issues. Let's go ahead and do nothing to use. We're just going to use exported symbols. So let's define our def package. Let's go ahead and say we're in this package. Oh, wait. Hold on. Oh. Oops. That's right. That's why I need to do this. CL def package. CL in package. Now I'll be fine. That's fine. That's fine. MRS. Okay, so we're now in there. Now we have to do CL. Because I'm not using the package inside of my def package, I have to use CL colon and get the exported symbols. So we now define our own and. So now this is defined, this method combination is defined in our package, our CL pack, RV test package. Now, how would we use this? We can use this by just simply, let's say that we define a class base, okay, and base has let's say it has a simple member called x. We'll just say init arg x, init form nil accessor x. Okay, so now base is unbound. Hold on 1 second. CL, there we go. Common with 1 second. This is, oh, I have to probably do this. I have to probably say CL standard object because it's no longer bound to anything. Oh, right, hold on. Actually, This should have worked. Give me a second here. I think my REPL got messed up when I did this. One second. Okay. So there's while I'm doing this, I just saw another question here. Do you think if the CL community built something like WordPress and the CL would be okay? So the question is talking about CL becoming mainstream. So I have a couple of thoughts about this, mainly because it comes from different angles, really. Um, One is if the CL community built, there's a lot of things that the Common Lisp community and Common Lisp industry, let's just say, has built that most people use, and they just don't say that it leverages Common Lisp. Chatbots is one. There are many chatbots that were designed in Common Lisp. Uh, Another thing is databases. For many of you who have used Allegro Graph or Allegro Cache or any of its database products from Franz, you probably already know that they have both the Common Lisp has a query language, but also they have created Python connectors. They've created other connectors that hide the fact that the core implementation, core technology, is implemented in Common Lisp, but the main focus of the actual application was written in another language of choice. Uh, I don't know if Word, something like a content management system, would make Common Lisp particularly mainstream. Mainly because of the fact that content management systems tend to focus on a particular community that, while Common Lisp will certainly make it easier for them to use and probably create their websites, which one thing I would say a content management system really makes it easier to create. Um, there are other aspects of, say, Common Lisp that they would never actually use on a day-to-day basis. And as a result, um, while they are leveraging Common Lisp as a technology to build the product, other folks will be like, you're not leveraging the full power of the application. So the real question is, can you design something where the advantages of leveraging Common Lisp become more apparent. And if you could show that off, then Common Lisp will become mainstream. I think many of the so-called containerization platforms that have been blowing up in the last decade or so, a lot of them could have been probably dispatched or even created on top of Common Lisp. So you have a single tool to actually go and uh, dispatch and be able to deploy and design larger scale systems without having to go and say create your own meta library or meta language and then subsequent parsers. All right. Now, I'm hindsight is always 2020, and there I'm sure it's the folks who designed those great systems, whether it be Docker or Kubernetes. Um, would have thought this through and thought, okay, it would be um, easier to find people maybe who are trained in, say, YAML and so forth to actually go and adopt this particular technology if it was designed in their particular markup of choice. But I would make the argument that if what you're designing is a domain specific language, which a lot of those system architecture deployment things are, those markups are. Um, Using a EDSL inside a very sophisticated macro facility like Common Lisp would actually do you some justice, just because of the fact that you're getting a lot of stuff out of the box for free. Um, but again, um, I'm not the designer of those tools. I just see the advantages of leveraging it there. Um, Is there a killer application now that Common Lisp could totally design for? Of course, a lot of the LLM stuff and a lot of the AI stuff that we see blown up, that's kind of been the better bread and butter of the Common Lisp community for decades before the high performance world kind of like caught up and we were able to move a lot of Lisp's features into other languages. So going back in that direction, I think would be great. And I think one specific thing that we still have kind of an upper hand for because we do source to source transformations is in the world of genetic programming, not genetic algorithms and evolutionary computation. Um, I have not seen that kind of work create products in any specific shape or form just because deep learning and massive computation has sort of made folks a point into thinking that oh there we can actually end up brute forcing a lot of this stuff, but I still make the argument that for energy efficiency more evolutionary approaches is probably a better approach just in the long term, just because as much as I would like to say that we have a lot of databases and hardware is getting cheaper and storage and facilities are getting cheaper and so forth. 90% of supervised learning and 90% of neural network learning, and this is just me spewing off my own opinion on this, and uh, any deep learning and reinforcement learning experts, please feel free to correct me if I'm wrong. Um, I feel that 90% of it comes from training, and training comes from the quality of data. And if the quality of data is massively dirty, then you're spending a good portion of your time cleaning it up. And if you end up having to spend that, then it's kind of a law of diminishing returns, even if you have a large data set, just because who's going to spend like I'm going to say at the bare minimum, 4 to 6 months cleaning up terabytes or even petabytes of data to get something meaningful for them to actually do business analysis on. There has to be a much better, a much more feasible way to do some of that stuff. Hopefully that makes sense to you. Like that's kind of my long-winded way of saying common lisp can easily become mainstream if we end up leveraging it for systems programming tasks and other tasks where we see that languages like Go and Rust are leveraging. And with its interactive capabilities, you get a lot of stuff for free. One other thing I would also like to point out, and this is recently something that's becoming more and more apparent, is with the kind of push for memory safe languages, because Rust is the most recent example of this. And let's be honest, since Java was introduced in 1995, um, this has really become kind of the push that everybody's been finally getting to understand, especially with the rise in number of security incidents through the use of languages like C or C++. Um, Common Lisp could become a contender in that space too as well. If we actually encourage people to really understand common Lisp garbage collection it's pretty damn good, and it still gives you performance as good as C. So anybody who says otherwise hasn't probably spent enough time tweaking their common Lisp applications or even understanding their common Lisp VM, because each common Lisp compiler not only has the ability to create dumped images, you have the ability to actually do that. How can we improve on package documentation? Is sometimes for big. Okay, so this is a great question. Um, how can we improve on package documentation? And this is something that's a little near and dear to my heart, just because I've been, through the last 4 years since I started this stream. One of my goals is packages that I have a kind of interest in. I've been trying to at least give beginners and other folks the ability to actually go through and have videos to kind of show them some of the most common use cases. Now, I don't know whether or not I've succeeded or failed miserably on this regard, but I will say for folks, one thing that the community can do as a whole is start just making up videos as you explore these libraries, and let's get some more get started documentation going. There's various efforts on various forums on how to convince project authors to do this. But I see, since these are all open source projects, at least the majority of the ones that most people are using daily, there is a there is a way for us to actually get together and actually do some of this stuff. And if more folks are interested, I am more than happy to, like, have kind of separate streams where we actually sit down and start, talking through particular libraries that folks are interested in. But this is going to have to require a community effort. Different packages written by different authors were at different levels of maturity at the time that the author was interested in. Some have moved on to other projects and even bigger and better things. And, coming back to it's going to require, just um, uh, require some folks to kind of like step in and do some of the stuff. And I feel the Common Law Study Group is at least trying to take part in that and try in the best way and shape it can. Other questions? Any questions from the peanut gallery in the Jitsi meetup? I'm just kidding. Everybody's in. All comments are welcome. All questions are welcome. Okay. Well, we're gonna still, continue on for a little bit longer. But I would hope that folks that have questions, feel free to drop, a question in the chat, and I will gladly answer this as soon as possible, as soon as I see them. I'm going to pose. Uh, does CL have an official website? Yes. There's a couple of websites that you can uh, look at. The most active one from the last time I saw was lisplang.org, if I remember correctly. Um, this has a bunch of tutorials for, and it actually has a nice list of all the communities um, for folks to actually go look at. Again, I will post this comment inside the YouTube description. I'll put the link to the Lisplang community, but there's a bunch of nice resources on the Lisplang community for folks to to read. And one of the nice things they added most recently I saw was when writing libraries, what to do, and guides on continuous integration. Okay. To the commenter about the um, about talking about in the sense that made Python useful for scientific programming. Are you talking about writing tutorials that for data science? Because I would be interested in actually seeing some of that stuff, just mainly because um, that there that goes into some stuff related to recent things that I've seen from just folks moving on the NumPy community and moving over to creating NumPy equivalents inside Common Lisp. I encourage folks to look at NumCL if they are um, uh, interested in that. That I think that's still that's still quite an active project, just because that's been created by I believe it's being funded by IBM um, to actually do some of this stuff. Um, so for folks who want to look at this, this is in this guy. That I'll again post that inside our comment our YouTube description too as well. Uh, um, okay, so there's a question about slime versus slide. This is a very interesting question I've seen quite a bit. So I would actually make the argument that there is three now available REPLs for various folks beginning into Common Lisp. One obviously is the standard classic ones that most Common Lisp documentation, Common Lisp book references, and that is Sylvester or Sly and Slime has someone mentioned. But then there's also recently, if I remember the name correctly, I think it's called Alive. Yeah, it's Alive. So the Alive extension is a very more recent extension to actually run Common Lisp on top of LSP and use VS Code to actually go in and hook into it. It's still somewhat of a work in progress, as the author mentions. If folks are active, like using it, I encourage you to post pull requests and fix issues to see this. But this is probably the most recent thing that I've seen that I thought was kind of nice, just because um, Alive is short for the average Lisp VS Code environment, and it's built on top of it. Okay, so there's a question on clog. Uh, I personally have not used clog. And for folks who don't know what clog is, it's the GUI library, the omniscient GUI library that was created by Ravi Bhattan um, in like I think it was uh, it's now been 2 years. Um, um, by by David Botten, and he actually wrote a very nice set of tutorials on how to leverage Clog. Um, I just have not had the chance to actually go and dig into it. I might end up creating a series of talks on top of this just for us to explore it, just because it looks like it's now fairly mature now, so you can leverage and do various things in here that allows you to write quick web applications. And this is something I've been personally looking into, just mainly because uh, I feel like for many folks who are doing web programming, they often dismiss Common Lisp in favor for things like ClojureScript, mainly because of some of the integration with the different web browsers and so on. But if you're doing a transpiler like ClojureScript or even Dart or what's the other one that keep thinking of? TypeScript. Um, I don't think leveraging Common Lisp is any, you know, any more difficult. Honestly. So there was a question about my recommendations for writing web applications. Honestly, for back end stuff, it really like back end services. Um, it if all it is honestly, line of business applications, like backed applications, half the time you're just basically writing a query against a database and be able to quickly respond back to a particular response. And so I would make the argument that Common Lisp is a perfect contender for this, and it would be easy to write a common Lisp backend and then sit that on top of an HTML front end that is probably deployed on a static storage site like S3 or something like that. So you don't have to have a lot of what's it uh, isomorphic type of like applications running both on the server and the client. So that's kind of my recommendation. Common Lisp for the for the back office. Um, if you can do transpilers, I would also say write your front end in Common Lisp and then transpile it to HTML, CSS, JavaScript, and then have it deployed on some static site. But that is my recommendation. Other questions? This is great, guys. Keep them coming. Now, for the A for the AI inclined folks, I strongly encourage you to first look at Common Lisp for your AI needs and see if there's already a library and or applications and or even programming examples written for Common Lisp for your short use cases before you reach out to more heavyweight libraries like say um, uh, Python with PyTorch or whatever for deep learning. Just because, again, a lot of supervised learning is basically data ingestion, data cleanup, and then setting it up for training. And um, if you're just doing some stuff that requires some basic algorithms inside leveraging some sort of learning mechanism, whether it be regression or so forth. Um, or even a simple three-layer or multi-layer perceptron network. Common Lisp has those libraries available to you. It does not have a deep learning library as far as I know, but there have been recent efforts into even writing that and resolving that particular weakness just because of the recent things. Because again, okay, comment on this. If someone can tell me how I can get um, Professor Friedman here, I would totally. There was a comment about Lex Friedman. Lex, if you're watching the Common Lisp Study Group, I would love to have you on here. It would be awesome. Um, but we'll see. Ah, this is actually a pretty interesting question. Okay, so sort of let's address this in the order in which they came. So the first question about ONNX, I do not know what ONXX is. For pre-trained networks in Common Lisp, um, I would, uh, if you can give me something more specific on what that is, I'd gladly answer that question. But I haven't come any. Clearly, the answer is no, based on the fact that I don't know what ONXX is. So. Second question about why macros are not first. So this is an interesting question. Why are macros not first-class citizens in that we cannot pass them around as a variable? So I have to come at this from different for different angles. Um, honestly, so first we're going to have to come at it as what is um, a macro. A macro is a syntax transformer. All right. It is a syntactic abstraction. When you define a macro, it's not actually a function pointer. Okay. So it isn't actually stored in any particular way other than has a symbol. Okay. And we can actually see something like this if we define what an internal macro. So let's go and do a quick example of this. Let's define a macro my when, okay, and then we do a a condition, c, and then we have our um, rest body, or actually I should say body. Okay, so let's take the classic uh, example. Um, my when, if, comma, c, comma, at body. Okay. Um, did I mess this up? Hold on a second. Did I mess up? Dedicated output. Sign up my when. Oh, sorry. Body. There we go. So we now have our my when. Let's just check. Print. Okay. So let's look up what my when is actually. So when we describe my when, you'll see that sorry, when I actually type in describe correctly, you'll see that the common list defines my when has a macro with a particular lambda list, but it's not defined as and it is a symbol. Okay, if we look up the actual symbol of my when, you will end up getting. Hold on, let me see if I can actually get the actual symbol for this. 5 um, uh, symbol. Uh, Let's see if I can say describe a compiler object. Describe object. No, that's not fine. Describe is. Um, I was hoping that I can actually uh, get the symbol object that so I could show you the actual object expansion in Sylvester. Give me just 1 second. There is a way of doing this. It's just I have to go remind myself how to get this. Um, so um, okay, let me see if this actually. There we go. So when we look up the symbol, we can actually look up the symbol up. It is a macro with a macro function here, right? This macro function is the specific thing that you need to take a look at because although internally it is a function, it's a compiled function that actually generates code at compile time. Okay. It doesn't that means that it's not a function that returns a type that can be leveraged as a variable. And since contrarily to most popular beliefs. It's not that it's just it's a strongly typed language, albeit that there is dynamic typing in it. It is that when a variable is assigned something, there's a type associated with it. What is the type of the macro becomes a question. Because we don't have it's a syntax generator, we have no way of knowing what its type is. It's just going to be a series of AST nodes. If you create that kind of assumption there, you're actually restricting the ability to do macro transformations. So that's why macros it makes it difficult for macros to become to be anything but a compile time mechanism. It's not a runtime mechanism where at runtime you could generate a syntax transformer on the fly and be able to pass it around and then execute it. So the comment that someone made about the execution of compile with time becomes is precisely what this is about. Because it is a macro function and its type information isn't has strict. It's leveraged at a different part of the infrastructure, and therefore it's not something that you could just assign and execute when you want to willy nilly. Okay, so there was a comment about ONXX. For folks who are watching this who want to know what ONXX is, it's a part of it stands for uh it's actually ONNX. It's the Open Neural Network Exchange format. It is a format that allows you to take pre-trained networks and be able to um, leverage them. Honestly, I think the answer to your question, um, uh, I haven't seen anybody leverage this, but that's only because I haven't actively looked for it. But this would be something that now that am aware that this is there, I'm sure that somebody else has looked into the possibility of leveraging um, ONNX in some way, shape, or form to inside Common Lisp. And if not, this is a project possibility. um, uh, I see a project possibility to actually build such a library. Um, but obviously that would require us to actually sit down and understand how this all currently works. So, other questions? Any questions from the Jitsi? There, you can ask tons of questions. All right, for folks who are wondering if it's okay to keep asking away. I mean, the more questions you ask, the better. Um, so, question about okay, so in the order in which I received them, I will answer the question about the meta object protocol in just a second here. First question: No, why is there no lazy evaluation with macros? Again, this goes back to the compile time mechanism related with macros. At the time that Common Lisp was designed, eager evaluation was the common technique that was uh, created. Um, when Haskell was created, interestingly, I found out that at least some of the earlier compilers for Haskell, and even it may have been Miranda at this point, but I'm not entirely sure. Um, it's Those prototypes were created in Common Lisp actually, or Lisp at that point. I'm not. It may have been actually Intralisp that was created in, and or earlier versions of Common Lisp version 1. But either way, lazy evaluation was implemented via a closure. Now, is it possible to actually have this as a first class feature for creating macros in? Yeah, but I think since it's a syntax transformer and compile time mechanism, I think it is up to the macro author to determine whether or not their macro requires lazy evaluation or not. And if that is the case, then there are plenty of libraries out there. CL Lazy is one of them that actually implements lazy evaluation that you could leverage inside of your macro design to actually go in and implement that feature. But again, um, it's not so much that it couldn't be implemented because again history shows that we was implemented in some of it. It's whether or not it should be a feature that is turned on by default for macro expansion, and that's something that I would leave up to the macro author, the person who's designing their particular macro. um can I explain what is the meta object protocol? Okay, so we've actually done a series on the meta object protocol, but I'll give you a quick answer to this. Uh, this is SR Muro. Um, uh, the meta object protocol is literally a it's based on the idea that you can design an object oriented language has an object oriented program. Okay. Um, what that means is your classes and the notion of what a class is and what an object is are themselves classes inside of this object oriented program. All right. So, what the meta object protocol did is inside Common Lisp, at least, it was basically the basis for you to define a series of methods and API calls, okay, literally protocols. Okay, a protocol for in the meta object protocol sense is kind of think of it like an API spec um, on how you might want to extend subclass inheritance. How might you want to deal with writing extensions that are fun callable, or that means whether or not they could be act like functions and so forth. So for um, Common Lisp, the meta object protocol includes things like being able to define what are called meta classes um, and so forth. Um, and the it has extensions for writing generic classes. And what this allows you to do, this meta object protocol, is you could take a def class, any class that you've defined has a def class, which is Common Lisp's approach to defining objects. And you can attach this meta class on top of it to provide additional functionality. Um, without actually doing heavy modifications. Um, yes, the answer is the common Lisp object system after the fact was designed on top of the current mop. Yes, that is correct, as far as I know. It actually inspired the meta object protocol, the common Lisp object system. In fact, you could define your own common Lisp object, your own object system on top of the meta object protocol as it stands today. I encourage you to read Dr. Cazellas's book because it turns out that it actually ended up inspiring a lot of what we now see in other languages. Most specifically, I would say the closest thing is Java annotations with annotation processors. Um, okay, so there's a question about why the hyperspec is still copyrighted. The hyperspec is copyrighted because it's owned by LispWorks, as far as I know. It is an implementation of the ANSI standard too as well. Um, but as there is an open source like PDF of the full standard from what I remember. Somebody mentioned at least elsewhere that there are open source like drafts that you can actually leverage in some way, shape, or form. Is there any library that implement the Rebol parse in Common Lisp? The Rebol parse. I don't believe I've heard of this, but let me. I'm sure there is. If it's not, um, yeah, I can't really answer this question just because I've never actually. I'm not entirely sure what. Are you talking about the Rebol programming language, or are you talking about uh, something else? Sorry. Yeah, it's not even a programming language. It's actually uh, an exchange format. Yeah, I have not seen anybody implement this, but you know, never say never. You know. Um. So I'm gonna take this as my final question. My Lisp journey honestly has been. Oh, so there's two questions here. One, let's very quickly about what could be done to leverage Wolfram or use Wolfram physics on a graph database like Franz's. Um, I I'd have to see what APIs Wolfram physics has. Um, and how to tie in an additional data source like Franz's into it. But I'm sure that once that's done, it wouldn't be too difficult to do anything with. I mean, Allegrograph doesn't how to discourage folks from using other languages. They have a Gremlin API connector. They have a Python connector. You could write um, queer what they call procedures, like stored procedures in Common Lisp, in Python, in JavaScript. Um, from what I last checked, in Prolog for folks who are interested in writing stuff in Prolog. Um, and honestly, their Prolog implementation and Common Lisp implementation of stored procedures are pretty fast because they're very close to C performance in terms of the ability to get executed. Um, and they also have a Sparkle connector still, so you have that. Um, my Lisp journey, to answer this last question about my Lisp journey, is I started learning Common Lisp in 2006, so that was 17 years ago. Actually, it's turning on to the 18 as of I think it was September. It'll be 18 years since I've actually started my Common Lisp journey, and honestly, I still don't think I'm anywhere near um, uh, done. The more I learn about it, the more I feel like I have to design systems with it. And the more I design systems with it, the more I feel like other languages are lacking. Um, the only gripes that I feel that I have with Common Lisp specifically is the tooling ecosystem just for deploying applications. But that's not a fault of Common Lisp. That's or even the community's fault. I mean, times have changed, and we have different deployment mechanisms. We have different form factors that we've never encountered before when Common Lisp was designed. Um, uh, but I would say that the more I learn about it, the more I would love to use it. I do not have, sadly, any professional experience with it outside of maybe leveraging it for one or two internal tools that I've done at various jobs. Um, but after that was usually at a prototyping phase, to be quite honest, just because I knew other folks in the team would not appreciate me leveraging non what they would call quote unquote non-standard languages for deployment and maintenance. Because you have a different mindset when you're especially working at a job where training resources become an important factor as to whether or not you leverage something like, say, Common Lisp. And as much as I would love more people to learn the language and understand um, its facilities and be able to leverage it in larger scale software, I also know from my years in the industry that there are sometimes some decisions have to be made based on the humans that are all around in a particular project. So, you know, I'll just leave it at that. Can we change it? We could certainly change it, but we need to get more folks involved in actually writing out tutorials, writing out the libraries that eases people into leveraging it and then showing them the way. And with that, I'm going to conclude this Ask Us Anything. This was fantastic, very productive. Um, I more folks who watch this video after it's been recorded, if you have any additional questions, feel free to throw them in the comments, and I will possibly start up another, you know, ask us anything anytime for us, so that folks can join in and tell us about your experiences. Um, and I appreciate all of you coming today, and I'll see you guys. Um, Unfortunately, next week, I'm gonna have to. I won't be able to host the CL study week, study group, but we will be back after in the following week. So, thanks for joining.